The next data structure that we're going to look at is a set. So what is a set? A set is, again, I can define it with curly brackets. You can't define an empty set though, because if you define an empty set, and if you see what is a type of S, it would tell you that it is a class dictionary. You can't define an empty set. You can only define a set of numbers like 1, 2, 3, 4, 5. Now if I see type of S, it's gonna say it is a set. And if I do S of 0, it will say no, it does not support indexing. Why? Because a set is unordered. A set is unordered. There is no ordering for it. Okay, let's say for example, if I had done something like this, 5, 4, something like this. If I had defined things a bit differently. If I now print it, what happens? First of all, the order is different because I had started with a 5 first, but a 0 is come first, a 1 is come up, then 2, 4, 5, and 10. But what about 5 was repeated twice or thrice? Repetitions are cancelled out in sets. Sets do not allow the repetition, and if set does not allow repetition, nor does it allow indexing, which means it is unordered, and of course elements are not repeated. Okay, but you can iterate not with the index. You don't have an index, but you can iterate like this for every element in S. Print E. Alright, you can do that. You can just print all the elements in S. This is something that can be done with a set. Of course, let's say if I have a set which has 1, 2, 3, 4, 5, and if I had another set S1, which would be 3, 4, 5, 6, oops, I did a mistake. 4, 5, 6, 7, 8. I could do something like this. I could say S and S1. What are they? I will get a new set, which consists of elements in S and S1. Or I could get a set which is S or S1. Or I could get a set which means S or S1 will give me a new set which consists of all the elements in S and S1 without any repetitions. Or I could do something like S XOR S1, which would give me the elements in S and S1, but not the common elements. The common elements will be deleted. But it will give me all the other elements, 1, 2, 3, 6, 7, 8. These elements will be there in XOR, right? These are a few things that, you can think of when you do an XOR. Alright. Set operations can also involve S dot. You can add elements by just saying S dot add. Let's say 10. 10 will be added into S, but you can't add it with an index, so which means sets are mutable. You can't change them. Of course, you can't change them using the index, but you can of course do it using functions. S dot. You can copy, you can create a difference of two sets, you can discard, you can have a subset, you can check if it is a subset. If S dot subset over S1, is it a subset? No, it will give me a false. Right? So these are a few things that you can always do for methods that can be figured out by you if and when the need comes. But these are just the basic subsets so that you can just, in case if there is something which comes up, you can go ahead about it. Alright, let's go on for the next data structure there.